name is Karuna Singh. Welcome to the channel North Star Continuous Knowledge Excellence. In this video, we will get to know about the electrode stability test and diffusion mobility test. Now, our expert, Professor Himadri Bohidar, who is associated with National Center Excellence in Agro Nanotechnology, Terry Tyson Nanotechnology Center, India. He has 31 years of academic experience in teaching and research. His area of expertise includes nanoscience and nanotechnology, nanobiointerface science, soft matter science, polymer physics, biophysics. Will explain you in detail about this topic. So, to get complete information, watch full video without skip.
Using that electrode, an electrochemical cell, the experiment was conducted and a bare electrode was tested. First, you have to optimize the data reproducibility and the stability of the bare electrode, which is basically the gold nanoparticles modified glassy carbon electrode. Okay, there are 5 different experiments here. Sample 1, 2, 3, immersed, where the electrode was immersed in the colloidal gold solution for different instances of time, and you see 3 different measurements will give you more or less the same value. Okay, so that talks about the data reproducibility here. Okay, so A, B, C, and D, there are 4 different experiments, and they give you the value which are reproducible: 37, 37, 35.2. So plus minus 1 or 2 microampere is the error bar here. 21, 23, 22. Same thing. 25, 22.5, 22.75. Again, plus minus 2 microampere, right? And then the bare electrode is always 20, where there is no gold nanoparticle in it. So the testing of the stability is done here. If you take the anodic current, maximum anodic current, and plot it as a function of the square root of the scan rate, you should get a straight line, which implies that the electron transfer process is a diffusive process. And this is what is the test of that. For this particular electrode, you can see that there is wonderful linearity, bare electrode, then gold modified electrode, and also with the different electrolyte solution in it. It's showing beautiful linearity there, which basically means that the electron transfer process is diffusive in nature. Now the different neurotransmitters like dopamine, catechol, caffeic acid, uric acid, serotonin, etc., they're all listed here. This is the peak cathodic current, peak anodic current. 4 different samples are tested here. Okay, and this is the bare electrode value. And from there you see what is the sensitivity for different neurotransmitters here. For instance, you see the last 2 things. Serotonin. Serotonin has no cathodic current at all, 0 cathodic current. It only has anodic current. Uric acid, for instance, gives a very strong anodic current, 105. Now, compared to that, the response from caffeic acid is very poor, 16 for cathodic current and 25 for anodic current. Catechol has 74 as anodic current and minus 20 as the cathodic current here. So some amount of selectivity is already built into this detection process that we are seeing here.
Wait. Are you worried about your project, training, dissertation, internship? Don't think too much, because Nanoscience and Technology Consortium, in short NSTC, is giving you a golden opportunity to do the same tasks. NSTC also conducts workshops on amazing topics. So if you want to register in the workshop, the registration link is given in the description box below, or you may go to the website www.nanoschool.in, where you can easily enroll in the workshops. So just check it out right now.
It is responding, the cell is responding to certain neurotransmitters excessively, and it's not that sensitive to other neurotransmitters. That is what the table data tells us. Okay, now in order to make a differentiate between how much signal you are basically getting, this is our reference state. This is the bare electrode. This is the electrode with a sample. So where you see that this bare electrode, the minus 15 here, but with the caffeic acid, it's close to about 16, 17. The minus sign missing here, so minus 16, 17. So barely anything is happening here. So it's not going to work for a caffeic acid detection. For example, serotonin, you see, though there is no cathodic current here, but it is very highly sensitive to the anodic current detection, because the Bayer value was 5.2, and with the sample it is going to 37, 7 times more. In case of dopamine, you see anodic current is 21 Bayer electrode, with the sample it is 75, close to 80 here, 4 times. So this is going to be a detector for dopamine or serotonin, for instance. Whereas for caffeic acid, it's a very poor detector. So this is the inference that one gets from analysis of the different neurotransmitter markers in the electrochemical cell and their response to the current voltage characteristic. Now, there are many different ways of optimizing the electrode stability and also the electrochemical cell. You can look at the current ratio between the two, cathodic and anodic current, and for various samples, you see how the performance is varying, or the difference of the potential, the maximum cathodic current minus maximum anodic current. That also is a parameter that is utilized to check the stability of the electrode. So all these test needs to be done before you actually embark on a real detection experiment or sensing experiment in your lab. So a poor and regular, rigorous electrode characterization and characterization of the electrochemical cell is a must. Okay, so earlier I showed you the sensitivity data of the neurotransmitters as a function of cathodic and anodic current. This is the related information about the cathodic and anodic potential. I mean, the potential where the maximum current was noticed. So this can also be used as a parameter or a measure or a monitor of this sensing. Okay, then you see how the cathodic voltage and anodic voltage, they are changing. Now you see it's 20 here and 350 here, and the baseline reference voltage minus 350, and this is 400 here. So by comparison of the Bayer electrode behavior with the sample data, one can either look from the current value or from the corresponding voltage value to identify which is the right indicator of this sensing. So that depends completely on the sample and also on the experimentalist who wants to get a better signal to noise ratio. One has to choose these two methods accordingly. That is the choice that is left to the experimentalist.
I hope you liked the video. Here I would like to give you an important information that Nanoscience and Technology Consortium, or NSTC, organized the nanotechnology workshops on amazing topics. Also, I would like to tell you about the initiatives of NSTC in which you can also be a part of. Mentorship, patent commercialization, joint product development, research projects, consultancy services, nanomaterials for your research projects, training programs or customized training programs, workshops or customized workshops. One more thing, and that is, if you want the full recording of the previous videos, so you can contact us on info@nstc.in. Further, if you want to enroll in the upcoming workshops, then you can go to the website www.nanoschool.in. And yes, subscribe to the channel Knowledge Star and hit the bell icon to never ever miss an update. Thank you.
For more updates, subscribe to our channel, click the links shown on the screen to stay connected.